Hello everyone, welcome to the next lecture on the integral equation. Today I will explain you how you can find the resolvent kernel related to the Fredholm integral equation. Myself Dr. Harish Garg, I can explain this lecture with the help of the fully shortcut trick. You can follow my YouTube channel where you can find the playlist of the CSR UGC net, and you can see the last lecture was on the resolvent kernel for the Volta equations. Apart from them, the boundary value problems, differential equation and many more available lectures in this playlist. You can simply subscribe my YouTube channel for finding the more videos. Now before I start directly jump to the questions, let me firstly tell you what are the various shortcut tricks and how you can find the resolvent kernel and the solution of the Fredholm integral equation. Whenever you are thinking about the equations, or whenever you will solve this kind of the equation, make sure the integrations are from a to b, where a and b are my constants. Fine. So whenever you are talking about this kind of the equation that called as the Fredholm integral equation, then the first target is how you can find the resolvent kernel. The resolvent kernel, you can know this the formula for that. And what is the lambda? Lambda is my this value, that is the coefficient of this integration, and k of m, you can find the k of m by use k is called as iterative kernels. Fine, iterative kernels, and you can find from here. That means you can find the k1 is the initial, k2 as the integration of this, k3, k4 and so on. So that will take a lot of time, but how you can solve this question within the 10 to 15 seconds, how you can find the resolvent kernel, for that I will give you the shortcut tricks. As you know, in my last lecture of this one, resolvent kernel Volta equation, I already explained the shortcut tricks for the Volta equation. Now what is the shortcut tricks for that, how you can solve this question with the help of the 10 to 15 second time, that I will explain you these shortcut tricks. Remember, nobody have explained this shortcut tricks. I the only one is explaining the shortcut tricks free of cost for all of you. Firstly, whatever the kernel is given to you, find this limit a to b k of x comma x and check whether this integration is not equal to 1 over this value of lambda. Then once this property is satisfied, then you can find the resolvent kernel as here, that is whatever the kernel is given to you, x comma t divided by 1 minus lambda times a to b k x comma x, because this a to b k x comma x you already found it, and 1 minus lambda is there. So this is the way you can find the resolvent kernel without using this summation sign. Fine, but make sure this, once you find this, make sure this should be the non-equal to 1 over lambda. Once you can find the resolvent kernel, then you can find the solution of this as here, y is fx plus lambda, replace this k by the resolvent kernel and y with respect to this f of t, and after solving you will get the right answer. But make sure whenever you have to apply these shortcut tricks, this is not applicable, this trick is not applicable for the degenerate kernels. What is the meaning of the degenerate kernels? Like whenever the given function fx is either of this form, like whenever there is a positive sign, whenever there is a negative sign, and here you can see I can write this sine x plus this sine x cos t plus cos x sine of t. Again you can see whenever you have separate them like plus minus, then you can never solve this equation with the help of this resolvent kernel. However, if your k x comma t will be like here, so since there is no plus minus sign in between them, you can apply this shortcut tricks. So however, how you can solve this one, that I will explain you in my next lecture, but right now you try to learn how you can solve this. So this is the first shortcut tricks that I gave you in this lecture. For example here, so a and b are my 0 to 1. Fine, what is the kernel is e of x plus t, and you can see if I break them, it is a multiply sign, not the plus minus sign. So this condition satisfied. Fine, now you can find the k x comma x. What is the limit is 0 to 1. So what is the answer of this? X comma x is 2x. So what is the integration of this? E of 2x divided by 2 from 0 to 1. So what is the answer of this? E square minus 1 over 2. And clearly say, because lambda is not given, so I assume this is not equal to here. So can you find the resolvent kernel? So therefore, what is the resolvent kernel? Kxt, that is a given function, divided by 1 minus lambda times of this answer. Fine. That is the resolvent kernel of this equation, provided mod of lambda should be less than of 2 over e square minus 1. That's the simple answer of this problem. Look at this another one. Again you can see this is a function of the x, this is a function of the t, which is multiply sign. So what is the kx comma x? Integration is from my 0 to 1. 1 plus x, 1 minus x is a 1 minus x square. So can you find the integration of this? It's a x minus x cube over 3 from 0 to 1. So it is my 2 over 3, which is not equal to lambda. So I assume that lambda is not equal to this. So what is my resolvent kernel? That is 1 plus x, 1 minus t divided by 1 minus lambda times of this number, provided this value should be less than of 3 by 2. So you can simplify this. It is a 3 over 3 minus 2 lambda into 1 minus 1 plus x, 1 minus t. So this is the resolvent kernel of this question. So I hope you can subscribe my YouTube channel as well. So if you want to scan and join my WhatsApp group, you can join that. Look at this next question here. Again, which is, can you find this value? Integration from 0 to 1, it will be 0 to 1 x of x, that is a x square into dx. So what is the integration of this? It's a 1 over 3. So what is the resolvent kernel? That is k xt divided by 1 minus lambda of 3, provided lambda should be less than of 3. So what is the answer of this? 3 divided by 3 minus lambda times xt is the right answer. Can you find the resolvent kernel of this? So what is the integration of kxx, that is a x, it is my 1 over 2. So what is the resolvent kernel for this? 1 minus lambda over 2 into t is the right answer of this problem. You can see this is the question asked in the June 2012. Find the resolvent kernel of this function f of x plus x 0 to half phi of xi of this. So firstly you can compare them. Lambda is my 1 because the coefficient is 1. What is the kx comma t? That is 1. Particularly in this case, instead of the t, it is my xi. So now what is the kx comma x from a to b, from 0 to half? So what is that? Integration of the 1 is x, which is half. Clearly say it is not equal to 1 over lambda. Lambda is my here. So what is the resolvent kernel? kxt 1 minus lambda times of this answer. So lambda is my 1. Fine. So it is my 1 minus half. So right answer is my 2 is the correct answer of this problem. And you can see how many seconds you are needed to solve this problem. I hope you can subscribe as well as like my video of this. You can see this is solve the integral equation. So firstly, what is the lambda? If you compare them, it is my half. What is the k? X comma t? It is my x into t. So can you find the limit of kx comma x? So kx comma x is x square. What is the integration from 0 to 1? It is 1 over 3, which is not equal to 1 over lambda. Because so therefore the resolvent kernel will be kxt 1 minus lambda. Lambda is my half into integration of this. So what is that? It's a 6 over 5 into x t. So therefore your solution is y 5x over 6 plus here 0 to 1, that is a resolvent kernel, into f of t. This is my fx Fine. So what is the f of t? Is 5 over 6 into t. So now you can integrate them with respect to t. So what is the answer of this? 5x over 6 is 5 cancel, 6x is outside. So x over 2 from 0 to 1 t square. So what is the integration of this? 1 over 3. So that is a 5x over 6 plus x over 6. So the right answer of this problem is y is equal to x is my right answer. Okay, look at this. What is the lambda is 1. What is the kernel? Kx comma t is my 1. Now you can integrate them from 0 to half k of x comma x. So what is the answer of this? Half. Fine, because its answer is 1, integration of the 1 is my half. Clearly say which is not equal to 1 over lambda. So what is the resolvent kernel? That is a kxt over 1 minus lambda into integration part. So that is my 2. So therefore solution will be y, which is x plus lambda is my 1, resolvent kernel 2 into f of t. What is the f of t? Is my t. So what is the answer of this? X. It will be my t square from 0 to half. So the right answer is x plus 1 over 4 is the right answer of this problem. You can see about again, this is my fx. Fine. What is the lambda is? Half. What is my kernel? If you compare them, it is my 1. So therefore, what is the integration of k x comma x? So what is the integration of the is a 1. So this is my 1. Clearly say which is not equal to 1 over lambda. So what is the resolvent kernel? Kxt divided by 1 minus lambda into kx, x integration. So that will be my 2. So finally, the solution will be fx e raised to power x minus e over 2 plus half plus lambda integration of resolvent kernel into f of t. What is the f of t? Is e raised to power t minus e over 2 plus half into dt. So what is the right answer of this? Now you can simplify this. Is a half, is a 2 will be cancelled out. So what is the integration of this? E raised to power t minus e of 2t plus half of t from 0 to 1. So what is the right answer of this? E over 2 plus half. If you substitute the upper limit, e raised to power 1 minus e over 2 plus half minus, if you substitute the lower limit, 1, 0 and 0. So what is the right answer of this? E raised to power x, e raised to power minus of e, this is my plus 1 and this is cancelled. So e raised to power x minus x is the right answer, and plus x e also. So this is also cancelled. So y is equal to e raised to power x is the right answer. Kindly subscribe my YouTube channel. Okay, look at this another one. What is that? F of x is my x, lambda is my lambda, this is unknown, kernel will be my x into t. So what is the integration of limit is 0 to 1 kx comma x. So what is the integration of the kx comma x? Is a x square. Integration of the x square is 1 over 3, and I assume lambda is not equal to 1 over lambda is not equal to 3. So therefore resolvent kernel will be my kxt divided by 1 minus lambda times integration of this, provided lambda should be less than of 3. Otherwise it will be the infinity. So therefore your solution will be, so what is my solution? Y is fx plus lambda is unknown, resolvent kernel x into t divided by 1 minus lambda over 3 into f of t. What is f of t? Is t. Fine. So it will be x. I can take this is outside, x is outside. So the remaining part is integration is t square. So what is the integration of the t square is 1 over 3. So I can take this LCM 3 times lambda x, 3 minus lambda. What is the integration of this is 1 over 3. So 3 will be cancelled out. Fine. So I can take the LCM 3x minus lambda x plus lambda x over 3 minus. So the answer is 3 over 3 minus lambda x, provided lambda should be less than of 3 is the right answer of this problem. Okay, look at this another one. Again the limits are constant. So lambda is my 1 over 4. Kernel is my x into t. Fine. So what is the integration of 0 to pi by 2? Because the limits are my 0 to pi by 2 of x square. So answer is x cube over 3. Fine. So and clearly say which is not equal to 1 over lambda. Fine. So therefore your resolvent kernel will be kxt divided by 1 minus lambda, fine, into pi over 2 cube divided by 3, which comes to be, I can say 12 is the LCM, 12xt divided by 12 minus pi cube over 8. So now solution is y is equal to sin x minus x over 4 plus 1 over 4 from 0 to pi by 2 resolvent kernel, 12xt divided by pi minus pi cube over 8 into f of t. F of t will be my sin t minus t by 4. Fine. Now I can integrate them. So I can simplify this term as sin x minus x over 4 plus, I can consider this term is my alpha. Fine. I can substitute later on. X is outside, then 0 to pi by 2 is a t sin t minus t square by 4. Fine. Now I can firstly integrate by parts of the t sin t. What is the integration of this first function? Integration of second function minus plus cos of t. So it will be minus t cos plus sin t. Fine. Now what is the integration of t square by 4? It is cube by 12. So I can substitute all these values at here. So let me clear this screen. Now I can substitute the upper and lower limit both. So lower limit is my 0, upper limit is my pi by 2. So I can substitute this part is minus pi by 2 cos pi by 2 plus sin pi by 2 minus lower limit is a 0, sin 0 is 0, minus t square by 4, upper limit is pi over 2 cube and lower limit is 0. So clearly say this number is 0 because cos pi by 2 is 91, 0. This is a 1 minus pi cube over 8 divided by 12, and which is the same thing of here. Fine. So therefore my solution will be, if I substitute here, so it will be sin x minus x over 4 plus, it will be cancel out 3x over alpha will be my here, that is 12 minus pi cube over 8, and the answer of this will be 1 minus pi cube over 8 by 12. So clearly say if I take the LCM, this number will be cancelled out. So the right answer is my sin x over 4. It will be cancelled out. So 3 will be cancelled out. It is x by 4. So the final right answer is my sin x is the right answer of this problem. Okay, look at this another one. Fx is fx. What is the kernel is? Kernel is e raised to power x minus t. Now limits are my 0 to 1. What is the kxx? It is x minus x is 0, e raised to power 0 is 1, integration is my 1. And I assume, because lambda is not given, so I assume lambda is my non-1. So resolvent kernel will be e raised to power x minus t 1 minus lambda into 1, provided lambda should be less than 1. So what is my solution? Y is equal to fx plus lambda times 0 to 1 resolvent kernel e raised to power x minus t over 1 minus lambda into f of t. Fine. Now it is my fx plus e raised to power x common, 1 minus lambda common is from 0 to f, 0 to 1 e raised to power minus of t f of t dt. Now since f of t is my unknown, so that's why this is the right answer of this problem. Okay, look at this another one. This is my fx. Fine. Lambda is my half. What is my kernel? K of xt is my t. Then integration from 0 to 1 kx comma x. So integration of this is, what is the integration of the x is? X square by 2. So that is a 1 over 2. And since it is not equal to 1 over lambda, remember lambda is my half, so it will be the 2. Half is not equal to 2. So therefore we can find the resolvent kernel as function kxt, lambda is my half and this is also half. So it is a 1 over 4, is a 1 minus 1 over 4 is 3 over 4. So it is 4 over 3 into t. So solution will be y is 3 over 2 e raised to power x minus half x e raised to power x minus half plus lambda times resolvent kernel 4 over 3 into t into fx into f of t. So 3 over t minus half and minus half. Fine. So I can solve this. The first, this component is similar, minus half x ex minus half. I can 4 by 3 is outside, that's a 2 over 3, and then integration of, I can multiply them, it's a 3 over 2 this minus half t square and minus half of t. So let me firstly calculate this integration. So what is the integration of this? T minus 1 e raised to power t. What is the integration of t square e raised to power t? So that means first function, then second derivative, then here. Fine. Or you can do by parts also, but I know how you can integrate the simple. So third part is integration of the t by 3 or t by 2, or I can simply take integration of the t, that is my t square over 2. Now I can take the limit as 0 to 1. So this value will be my half. Fine. This value will be, when you substitute 1, it is my 0. When you substitute 0, it is my 1. What is the integration from the 0 to 1? When you take 1, it is my e. When you take 0, it is my here. So I can substitute all these values at here. So let me clear this screen. So this value will be, so this is e minus 2. Now I can substitute this value here. It is 3 over 2 e raised to power x minus half x e raised to power x minus half plus 2 over 3. So this will be 3 times of, so it is a 3 by 2, half times of this, so half times of this, half times of this, minus t by 2. Now you can see it is my 1. Fine. So I can say it's a 3 by 2 e raised to power x minus half x e raised to power x minus half plus 1 minus e over 3 plus 2 over 3 minus t over 3. Sorry, it's a 1 over, what is the integration of the 1 over 2 is? It's a single 1 over 2. It is not t by 2. So it's a 1 over 4. So it's a 1 over 4. So that means it is my 1 over 6. Now you can rest of the part you can do with the calculation, that will get the right answer. You can see from here 6 is the LCM, it is my 4 minus 3, fine. So 1 over 2, that's a plus 1 over 2, minus 1 over 2 cancel out. So the right answer is 3 by 2 e raised to power x minus half minus e over 3 plus 1 is the right answer of this problem. Okay, look at this another one. Fx is my 1. What is a kxt? 1 minus 3. So clearly say this rule is not applicable. Why? Because of this negative sign here. If this quantity will be like of this term, then you can apply the rule. But right now it is not be here because this is my separated kernel. Fine. This is my separated kernel because 1 I can written as x raised to power 0 minus 3x comma t. So this is a separate term, this is a separate kernel. So that means this shortcut tricks is not applicable for this problem because this is a degenerate kernel or called as the separated kernel. How you can solve that I will explain you in the next lecture again with the help of the shortcut tricks. You can scan and join my WhatsApp group as well. So you can see that many shortcut tricks are there which is applicable to solve such kind of the problem. I hope you can subscribe and comment on my channel as well. We will see the next lecture how you can find the resolvent kernel for the degenerate kernel things are. Kindly share, comments and like on my video. Best of luck students. Happy learning.